Now, in this video, we are going to discuss about the stress, strain and deformation in a stepped bond. So here, if you consider a structural member of a stepped section subjected to an axial pull, which is as shown in the figure. So this is a structural member of stepped section having section 1, section 2 and section 3, having A1, A2 and A3 are the different cross-sectional areas of the section, having L1, L2, L3 as the length of the sections, and axial load is P, which is applied for the entire section. So here, that's what we have explained. L1, L2, L3 be the length of the sections of 1 to 3, and A1, A2, A3 be the corresponding area of cross sections, and let P be the axial tensile load, and E be the Young's modulus, which is having the same material for all the sections. Though each section is subjected to a same axial load P, the stress strains and change in length will be different. So, if we are considering this the section, and then what is stress strain and elongation or the extension, because we are applying with the tensile load, so naturally it should be the extension. For the first section, what is the stress? Stress is the load by area of cross section. So for the section 1, we have sigma 1 will be equal to the same axial load is applied for all entire section for entire stepped sections. So naturally P will going to be remain the same. So P divided by the area of cross section for the first specimen or the section 1 is A1. Then strain is epsilon 1, which will be equal to sigma 1 by E. So what is sigma 1? Sigma 1 is nothing but P by A1. Substitute the value of P by sigma 1 as P by A1. So that will be equal to P by A1 into E. So then what happens? This extension is what is epsilon 1? We can also write it as delta L1 by L1. So what is epsilon 1? Epsilon 1 will be equal to delta L1 by L1 equal to P into A1 into E. So once you want the extension, so delta L1, so then what happens? You cross multiply that P into L1 by A1 into E. So that is how you will going to get this expression. So similarly, when you are considering for the section 2, stress will be equal to sigma 2 will be equal to P by A2. So what is epsilon 2? Epsilon 2 is nothing but sigma 2 by E. So what is epsilon 2? Epsilon 2 is nothing but delta L2 by L2. So you cross multiply L2 here. So delta L2 will be equal to P into L2 by A2 into E. Similarly, this for the section 3, sigma 3 will be equal to load by area of cross section at the section 3. So that is P by A3. So epsilon 3 will be equal to delta L3 by L3. And also epsilon 3 is given by sigma 3 by E. So P by A3 into E. So what happens? Sigma 3 will be equal to, you substitute the value of sigma 3 as P by A3 into E. So what is epsilon 3? Also we know that epsilon 3 is delta L3 by L3. So you cross multiply delta L3 as it is and L3 that is to the top side, that is P into L3 by A3 into E. So this is how you will be able to find the stress, strain and extension for the different sections of the member of the same material or the stepped section. So this is how you will be able to get this. So the total change in length of the bar, since we have the same axial pull for the entire cross section, so delta L will be equal to delta L1 plus delta L2 plus delta L3. So what is delta L1? Which is nothing but P into L1 by A1 into E plus P into L2 by A2 into E plus P into L3 by A3 into E. So you take out the common factor of P in P by E. So you are going to get it as L1 by A1 plus L2 by A2 plus L3 by A3. So if the section is made of different materials, then what happens? You will going to get delta L will be equal to P into L1 by A1 into E1 plus P into L2 by A2 into E2 plus P into L3 by A3 into E3. So take out the common factor of P into L1 by A1 into E plus L2 by A2 into E2 plus L3 by E3 into E3. Since the materials is made out of different materials, so naturally E1, E2, E3 will going to come into the picture. Otherwise, P by E into L1 by A1 plus L2 by A2 plus L3 by A3, which is shown as shown here. So this is how you will be able to show the derivations of the different cross sections having the stepper member having the same load with the same material, and also on the different cross sections of the different materials with the same axial load applied on the stepper member. Thank you.